So, in the final step, step 3 of our simplifying and solving equations process, is the actual solving. So far, step 1 and step 2 have been about simplifying, cleaning up the equations so that there's less to do. So by the time you get to step 3, which is solving, we get something like this, something that's a little bit more straightforward and clean that takes less work to do. Now, in this case, once again, we're going to get away from the first two analogies we used, the grocery analogy, the balance scale analogy, and we're going to try a third one which suits this nicely. And it has to do with driving directions. At some point in time, either we have or our parents have had to print out or look up directions to get someplace new that we've never been. And it always gives us those directions, go east 4 miles, go north 12 miles, go west 2 miles, and you reach your destination. But those instructions never have the way back, especially when you print them out. They always have the directions to get there, but they never print the directions for getting back. But we usually don't need to, because we just basically undo the directions that we followed to get there. Well, with solving equations, it's much the same thing. Think of your equation as a set of driving directions. All we have to do is list out step by step the directions in the equation and then undo them just like you would undo driving directions. So let's take a look. Now, think of x as our starting point. X is our beginning location. I'm going to put my road map over here to the side. And then if I look, I've got two different things here that it seems like they've done to x. They've added 4 and they've times x by 3. And now it's just a matter of which one came first. Well, the nice thing is we already know the rule for that. It's order of operations. Order of operations says that certain things have to be done before other things. So when somebody made this equation, they must have done the multiply by 3 first, because as we know with PEMDAS, or order of operations, multiplication comes before addition. So whoever constructed this equation took x and first multiplied by 3. Then they did addition with plus 4. So now our job is basically just to undo the work they've done. Think of it as a roadmap. If I go back up and just kind of pull a U-turn here and I go reverse order, because again, think about driving directions. Driving directions, you wouldn't go from top to bottom again if you're trying to get back. You would start with the last step you did to get to your destination and then undo it to start getting back home again. So in this case, the last move they made was to add 4. So our first move will be to undo that by its opposite, subtract 4. So minus 4, and we're putting it here because it's intentionally done to get rid of that plus 4. And of course, we still follow the rule. What we do to one side of the equation, we do to the other side. We want a balanced equation. So 3x I haven't touched yet. The plus 4 minus 4 opposites, so they naturally disappear, equals, and then 19 minus 4 is 15. So that takes care of that step. Now, the other step that was in this equation, or driving directions, was to multiply by 3. So now we need to undo that. Well, the opposite of multiplying 3 is to divide by 3. So over here, if I divide by 3, what I do to one side, I do the other. Timesing by 3, dividing by 3 cancel each other out, or think of it this way, 3 divided by 3 is 1, or 1x, and 15 divided by 3 is 5. Takes care of that, and it gets me back to my original starting point, which was x equals 5. So this is how we kind of think of the whole roadmap analogy, that if we think of an equation like roadmap driving directions, all we have to do is pull a U-turn and undo those directions step by step to get us back to x or n or whatever we're solving for. Alright, let's try 2 more. Take a look at this equation. K divided by 3 minus 19 equals negative 13. So once again, our first job is to just decipher these driving directions. Let's figure out the roadmap. In this case, k, our variable, is our starting point, and what they did to it first, we have a choice here. Subtract 19 or divide by 3. Now once again, to figure out which one it is, it's all about order of operations. What comes first in the order of operations? Subtraction or division? We know it's division. So they must have taken k, then divided it by 3 to create this part of the equation, then they subtracted 19 to get the rest of it. Okay, so now what we're going to do is we're going to go in reverse order. In order to get to where we are now with this equation, the last thing they did was subtract 19. So if I pull a U-turn and I undo that last move, my first move becomes to add 19. So plus 19. What I do to one side of the equal sign, I do it to the other. And this, of course, cancels out. They're opposites. Opposites always cancel each other out. So we get k divided by 3 equals, and negative 13 plus 19 would be 6. So it takes care of that step. Alright, now the rest of this equation, they took k and divided by 3. So our next step to undo is to make a move where we multiply by 3, because multiplication and division are opposites. So over here we multiply by 3, multiply by 3. Now over here you can think of this as 3 over 1, and if you remember from previous years, anytime you have a problem like this when you're multiplying with fractions, you can always cross cancel, in this case the 3 and the 3. So we get k over 1, which is just k, and here we get 6 times 3, which is 18, and we've arrived back at our original starting point of k. Alright, one more. 21 equals negative 4v plus 33. Now, don't get thrown off by the fact that what we're working on is on the right side this time instead of the left. It doesn't matter. It's still the same basic idea that we're trying to solve for our variable. So let's take a look. V is our starting point. And once again we have a choice. Did they add this 33 first, or did they multiply by this negative 4 first? Well, again, multiplication comes before addition, so what they did was they took V and multiplied it by a negative 4. Then they added the 33. So, if we pull our U-turn, their last move was to add 33, so our first move should be to subtract 33. Minus 33 here, minus 33 here. These are meant to cancel out. 21 minus 33 is negative 12. And that gets us partway back. Now we go to here. Now, one little thing to remember, when we undo things, we're only undoing the operation. So in this case, multiplying by negative 4, the opposite would be to divide. The negative 4 still stays a negative 4, so don't accidentally do the opposite of that too and do positive 4. It's just the opposite of multiplying is to divide. The number itself that we're using stays the same, negative 4, negative 4. So over here, divide by negative 4, divide by negative 4. Over here, just like in the last the first example, these just cancel each other out and we end up with V. And negative 12 divided by negative 4, negative divided by negative is positive, 12 divided by 4 is 3, and that gets us back to V. And if you want to, you can flip your answer around, but it really doesn't matter. V equals 3. Alright, so this is the idea of using the roadmap, or the roadmap process, to solve equations. So let's give this a try in the next set of example problems.